Welcome back to Decoded, where we make complex things simple. My name is Rosa Shamase.
And my name is Kirsten Lake. And today we've got a very interesting topic. We are diving into space tech. So, what if the future of space travel isn't about burning rocket fuel, but about harnessing the power of electromagnetic fields? Our guest today is working on propulsion technology so revolutionary it could rewrite the rules of space exploration. Paul Stansell, CEO of Solid State Propulsion, is pioneering systems that use no traditional fuel, no moving parts, just pure physics to propel spacecrafts farther, faster, and more efficiently than ever before. Imagine satellites that maneuver with metallic fuel, deep space missions that don't rely on volatile chemicals. This isn't sci-fi, it's solid state propulsion, and Paul's team is making it a reality, with potential applications from cleaning up space debris and enabling space travel. This technology might just be the key to unlocking our solar system. Paul, welcome to the show.
Thanks, Kirsten. Great to be here.
I have to ask, when you first realized this technology could work, did it feel like you were cracking open the future?
A little bit. I remember it was back when I was at WITS studying, and I was just going through some calculations of the potential of some of these systems and then comparing it to what's used today. And then it did feel like quite an exciting moment of like, okay, maybe this makes a lot of sense to explore.
Okay,
Yeah,
so
nice.
you started this idea while you were still a student.
At Wits.
Yeah, exactly. So I got 3 degrees in physics, so I was definitely thinking about this for a long time. And even in high school, I was doing science fair projects like testing if plants could grow in a vacuum chamber, like to see if plants could grow on Mars. And then I got into like space propulsion projects, and that's actually how I found out about vacuum arc thrusters and this kind of technology.
Okay,
Wow.
so if you can simplify it, so here we
Yes,
try
yeah.
to make like complex things simple.
Simple.
So if you could explain what you've built and how it all works in the simplest way possible.
Sure. Okay, awesome. So the key technology is called a vacuum arc. And so basically it's just like an electrical arc, but in a vacuum. So in space or in a vacuum chamber.
Yeah.
So the simplest way to imagine this is if you have 2 pieces of metal, right? And you have almost like a welding or like a taser or like a lightning bolt, like you have a pulsed arc between them. And if you set this arc up in the right way, you actually turn one of the metals, one of the electrodes, the cathode, into a very hot plasma that shoots away into space. So it's a little bit esoteric. Yeah, you think about all these metals and arcs, but the simplest way is that you're having these arcs kind of like lightning or a welder or something like that, but you're turning metal into plasma, and this whole system functions like a rocket. So you can use it in space, and that's basically the key technology.
So there's no rocket fuel being used.
Exactly, yeah. So to get into space, you probably still want to use a chemical rocket fuel. Exactly. So imagine like a space shuttle or something it's burning a lot of propellant to get into space. But now once you're in orbit, you can switch over to a system like ours where you're just making a plasma, and all that you have to put in is electricity, and you use the metal. So you don't need anything explosive. You don't need to burn any fuels. So those are some of the advantages.
Wow. And does that actually maintain
Was it? Yeah.
it actually maintains like your speed?
Yeah, exactly. So once you're in orbit, it's a little bit better to use a system like this because you can actually control how fast the propellant goes. So when you're burning propellants, it's just a chemical reaction. So it's just chemistry, and you can't really control how fast the fuel moves. But with electric propulsion, which is what our systems do, you can adjust how much electricity and energy you put into the fuel, which in our case is solid metal, and that allows you to make it much more efficient. So you can use less fuel, but the fuel's going much faster. So yeah.
Okay, and have you seen like a lot of tech companies starting to use your propulsion technology? Are you integrating with stuff like that? Do you know Elon?
No. No, don't know Elon. But so there are quite a few companies doing this type of electric propulsion. So some other ones use iodine, or most of them, they use liquids or gases. So the key differentiator for us is that because we just literally use solid metal, the whole system can be much smaller. And that's why the company is called Solid State Propulsion. So there's no liquid state or gas state.
Gas state, yeah.
Exactly. And especially with the more traditional fuels like xenon, the tanks required are quite bulky, and you need high pressures to store those. So especially for the smaller satellites, it becomes very impractical to have a highly pressurized tank. So then a system like ours that's completely solid state, just turning metal straight into plasma, is more attractive. Yeah. And then,
Yeah, no, that's incredible. Yeah.
And then the other thing I was going to say is, sorry to cut you off, but what's also exciting about using metals is that there's a lot of metals in space, like all around. So on asteroids, there's a whole class of asteroids that are basically just metallic. They're called M-type asteroids, and they're like iron nickel alloys. Which is pretty cool, right?
Wow.
And then there's a whole bunch of other asteroids that are carbon, basically. And you can also use carbon. So very long term, the exciting thing about using a technology like ours is that you could feasibly land on some of these asteroids and actually refuel and get fuel straight from the asteroid.
That's incredible.
Whoa.
Yeah.
So like for long, I'm very sci-fi and I get very excited about things like this. But like, if we were trying to build something like a Nexus vibes, right, that could travel for, thousands of years across space, would you be able to power it with your solid state thing?
Yes. Yeah. 100%. Yeah. And actually, so while I was still doing my master's, I actually managed to get a real piece of an asteroid. So I got a real metallic meteorite. It's actually a long story, but I had to get a Nigerian meteorite because actually, like, all the South African meteorites are protected under the Heritage Act. So we couldn't use any South African meteorites. Yeah. So even though they fall from space, the government technically owns them.
Even if they fall in your backyard.
Yeah, even if they're in your backyard, the government technically ons them, and
so
you can't
keep quiet about
do anything with them. Yeah. Exactly.
Don't tell the government.
Don't tell the government.
Exactly.
They'll tax you.
So, so I was actually able to get a piece of this Nigerian meteorite that was this classic M-type. So it was an iron nickel alloy.
Yeah.
And maybe, you can throw up some pictures, but they have a really cool crystal structure which forms in space, which is quite cool. But we were able to test a piece of this meteorite, which is basically an asteroid, in our thruster, and it worked really well. So we kind of proved the concept, which was really nice.
Okay, so when you're saying solid state, right, does that mean that you take the metal as is, like in the current state, in that solid state, and you just... I'm trying to imagine this tech, right? Because I'm not I'm not a rocket scientist or anything. But what I'm trying to imagine, you take this solid thing and then you put it in the engine, and the electromagnetic force of it is what fuels the engine or whatever.
Yes, exactly. So 100%. You don't need to process the metals. And when we used this meteorite, we didn't process it. We just cut it. And it's the negative electrode, the cathode. That is turned into so just to go slightly technical for 2 seconds.
Going into science. I did
this. Basically, you have an interface where there's a cathode, and then you have an insulator and an anode.
Yes.
And so that interface is very important. And that's there's a lot of design work to be done there. But then basically what happens in vacuum is, with the right circuitry, you trigger this arc, and then a little crater basically forms on the cathode called a cathode spot. And it kind of digs down into that metal and turns it into plasma that's moving very fast. So the metal is just solid, and then you trigger an arc, and then it's a small amount of the metal, but it shoots off at 10 kilometers per second or more, which is 36,000 kilometers an hour or more. Yeah, and then that's it. So,
and then also now, if I'm thinking about the physics behind it, right? Would you say that is kind of, it wouldn't necessarily be explosive in my mind, right? So if damage happened to the spacecraft or something, it's not going to actually explode.
Exactly.
So it's actually more safe.
Exactly. And that's actually, that's one of the selling points is
Safety.
Yeah, safety. And there was a client who wanted to buy a thruster like a couple of weeks ago. And so we were compiling the range safety document because if you launch a satellite, you usually launch it from a US military base. So there's like this very long document called like from like the mission commander, space systems command. And it's all these like details about that. And the fact that there is nothing explosive or pressurized definitely simplifies it.
So now you keep mentioning thrusters. So does your company actually build thrusters for other space companies? Or do you integrate that technology within their existing thrusters?
Yeah, so the main thing we do, we build thrusters and then we sell them to companies who have satellites. And then they put them on their satellite. Exactly. Yeah.
Okay. So there's in South Africa specifically, there's a market for this. We build satellites and things like that.
There is a little bit of that.
Or is it international more?
So far, everyone we've sold to has been in America.
Okay.
And then other prospects we have are in Europe. So it's mostly America and Europe where they build a lot of satellites. Yeah. And there are a couple companies in South Africa who make different components. Like in the Cape, and and that's basically what we all do. So we all make a subsystem. So we make a propulsion thruster, and then we sell it to someone who has a satellite, and they attach it, and then send it off.
So then, if Elon Musk does come to South Africa and he brings Starlink, would that open up more business for you then?
I'm not sure. Maybe, but yeah, I mean that's more on the internet side, but that could maybe add more awareness, I suppose. Yeah.
Yeah, because isn't it all powered by satellites?
Yes. Yeah. No, 100%.
So then you could maybe get some marketing in there.
Maybe.
Collab.
Yeah, get some there. And like also with you send satellites out. Mostly you sell your thrusters to launch satellites, whether it be for like network cellular companies, as Kristen's mentioned, Starlink. Now, Jeff Bezos's Blue Orbit, where actually you send people like you and I to space. Is that something that's probably in your future state plans?
Maybe. So right now the thrusters we work on, they're best used in space. They wouldn't work too well on the ground. You'd better off using a chemical thing like in the atmosphere. So I'm not sure our thrusters would actually send people from Earth into space, but potentially longer term, with some of that refueling, you could see maybe like say if people going to Mars, then you could get them into space, and then you could maybe use our thrusters on a system to take them to Mars or something. Could be cool.
Oh, that would be awesome.
Yeah.
So do you've studied lots of different space tech, right? So what would you say is one space tech myth that you wish people would stop saying?
I'm actually glad you brought this up.
I like the smile on your face.
This is my time.
I can see it.
So, guys, there is gravity in space. Okay. That is the biggest one. Is a lot of people are like, oh, there's no gravity in space. That's actually not true. There's almost just as much gravity. So even like where the space station is, it's about, say, 400 kilometers altitude up. It's in space. But the reason it stays around the Earth is because of gravity. And it's probably like 90% of the gravity that we experience just because it's really high up. But it's still like almost as much gravity. And then the reason like it's weightless is just that it's in free fall. So the best way to think about this is if you imagine like you had the Earth, okay, and then you had a cannon, and then you shot a cannonball and like it went so far and then it landed, right? And then you shot it further, and then you shot it further. If you shot it far enough and fast enough, basically horizontally sideways, like here's your cannon, you shoot the cannonball that way, it would keep falling, and then it would just keep falling round and round and round, and it would just stay, and then it would be in orbit. And that's what orbit is. So there's still a lot of gravity. That's why it's falling. But you experience weightlessness because it's in free fall. Yeah.
But then, but I understand that, right? So Earth would have a gravitational pull, the sun has a gravitational pull.
Exactly.
But now if you go outside of our solar system, then wouldn't the gravity there change?
Yes, that could be. There could be much less gravity if you went really far, like to interstellar space or intergalactic space. Yeah, for sure. But gravity, it acts over very long distances. So even if you like left our star, and you went to interstellar space, you would still be orbiting roughly in the same rate that our star orbits the galaxy. So
so it's there is gravity.
Kind of always
still gravity.
there
Okay,
somewhere. Yeah.
guys, if you think there's no gravity in space, there is.
Yeah, apparently there is.
Lessons learned. And then, okay, what's your favorite? They actually use this in space story.
Okay, so some of the smallest satellites that we have sold thrusters to are called pocket cubes. So pocket cubes are 5 by 5 by 5 centimeters, so they're really tiny. That's 1P, and then like 3P would be like those stacked. So it would be 5 centimeters by 5 centimeters by 15 because it's 3. And then CubeSats is similar, but it's 10 by 10 by 10 centimeters. Anyways, but what's interesting is some of these CubeSats and pocket cubes, some of these smaller satellites, they actually use, like the yellow measuring tape that you use like, for building stuff. They use that exact tape, not like no joke, as a radio antenna because it like flips out.
Whoa.
Yeah. So, and I'm sure you can find a lot of photos online of these small satellites, and literally it's not like, this is a different product. It's literally a measuring tape that they connect to the satellite, and then they wrap it around, and then it launches out of the tube, and it just, how the measuring tape just flicks out.
Springs out.
Yeah. Exactly.
Okay, that's wild.
Yeah.
So have you ever been inside of like a space simulator?
No, not really. You mean like
like what the weightlessness simulator that they have?
I've seen those
be cool.
videos with planes, and then when they do zero gravity.
Yeah, that would be cool. Exactly. So then, I mean, that goes back to why you can experience zero gravity, but in a plane because it's in free fall. Exactly. Yeah. So there's still gravity. No, but that would be really fun. Yeah. Maybe you guys should do a podcast in it.
We should try that.
Yeah,
we should try that.
Take a field trip.
We'll take a field trip to Merck. I will be there.
Okay, so what space technology from 10 years ago is now completely obsolete? Would you say?
It could be maybe certain chemical propulsion systems, so that's kind of like, as I was saying, the shift to using electric propulsion has really happened in the last 10 years. So there is still a lot of chemical propulsion in space, but there's more and more using electric because it's like can give you more total impulse, and it's kind of more reliable in many ways. Yeah. So that's maybe one.
Okay. Very, very cool. And do you think that we would likely ever be able to live on Mars?
I think so. Yeah, I think so.
How soon?
I don't know. Probably longer than most people think. It's probably like more like 50 years.
Why?
Before there's like a real
breakthrough in that
city there. I think people will get there probably in the next 10 years. But I think it'll just take a long time to
get there.
Build up. Just to get there and to build everything you need there, and like to have a real like city that you could go visit. But I'm sure it will happen. Yeah.
Love it. No, thank you, Paul. It was very insightful that we have our own locally built space company that does thrusters. And thank you very much for joining the podcast.
Yeah, thanks for having me.
Anytime. And guys, check us for our next episode where we'll dive into a lot of robotics and automation. My name is Lozi Shumase.
My name is Kirsten Lake.
And you just got decoded. That's how we do it.